Welcome, ladies and gentlemen. This is section 3.4, solving equations and solving exponential and logarithmic equations. To start, I just want to give us a little bit of a review. You've done some of these problems before, and some of these strategies can be used along with what we're going to go into later today. But for first, these are some relatively quick exponential equations. Like right here, one way to solve 2 to the x is equal to 32. Just rewrite 32 using base of 2. 2 to the what is equal to 32? Well, 2, 4, 8, 16, 32, so that's going to be 5. So here we would say x has to equal 5 because the bases are the same. Also the same can work with logarithms. If I add ln of 3 to both sides, I would read ln of x has to equal the ln of 3. So you can make the conclusion x has to equal 3. So these go relatively quick, and these are made to be a review for you. A little trickery in this third one. I'm noticing that both of those numbers have relations to base 3. I could rewrite 1/3 as 3 to the negative 1 all to the x. And of course 9, I could write that as 3 squared. So now I just set these two equal to each other. Negative x is equal to 2, so conclusion x has to equal negative 2. Same thing here when we've got our e to the x equals ln of 7. I'm sorry, that problem actually has a typo. It is supposed to read e to the x equals 7. And the easiest way to solve this is to actually take it from exponential form, put it into log form. So because the base of our exponent is e, that's going to be log base e. And when I say log base e, the easier way to write that is ln of 7 equals x. So that's just going a straightforward transition from exponential form to log form, and now you can type this right into a calculator and get your answer. But I'm perfectly fine with you leaving it as ln of 7. A couple more down here. Both these problems are very similar. So we have ln here, your base is e. So again, we have log form, and I'm going to take it and write it as exponential form. So because my base is e, that's the base of my exponent. E to the negative 3 is equal to x. And again, type that right into a calculator, you have your answer. When I write a log, the base implied is 10. Here it would be 10 to the negative 1 is equal to x. So 0.1 equals x. I know that one. We don't need to put that one in the calculator. Okay, so we're going to be using these with the main idea as of right now is to be able to solve these, you usually need to go from logarithmic form to exponential form, or exponential form to logarithm form. But the key is you must put in, it's either the log or the exponential form first. Alright, if you don't put it in the log or exponential form first, then you can't make the switch. So this is close, this problem here is close to log and exponential form, but not quite there. And the one piece that's out of place is this 3. So we have to think, how can I get that 3 to, how can I get this problem to look like exponential form? And it's by getting rid of this 3, by doing an operation to both sides. I can cancel the 3 out. Now I have 2 to the x. 42 divided by 3 is 14. And now that's straightforward exponential form. If I put it in log form, I'm going to have my answer. It's going to be log base 2 of 14 equals x. And you can leave it just as is. You don't have to put it in the calculator. If they ask for you to give you a decimal, you could type in the log of 14 divided by the log of 2. That's your change of base formula if you needed to get a decimal. But for right now, I'm perfectly okay with this answer. If you need a decimal, you'd use the one on the right. Okay, next up here. So again, this looks like it could be an exponential form, but it's not quite there yet. So what changes do we need to make to put this in exponential form? And there's really 2 of them. And just like when you solved equations in algebra, the 2 changes are getting rid of this minus 3 and getting rid of this 4. The question is, which one do I get rid of first? I hope you think back to your algebra days and think, yeah, you always cancel addition and subtraction first. Think order of operations. Right, so cancel out those two. I have e to the 2x equals 5/4. So I'm going to write this into log form. I could write log base e, but that is better known as ln. The ln of what? Well, I take whatever's on the opposite side of the equal sign from the base of my exponent. So, and then I say equals 2x. And then I could put log of 5/4 into a calculator, and I'm going to have to divide both sides by 2. So that would be the ln of 5/4, all divided by 2. That's going to be my value for x. We can put that into a calculator. So here's my calculator. I could just type in ln of 5 divided by 4, close the parentheses, enter, divide that answer by 2, enter. 0.111 or 0.112 if you want to round correctly would be our answer. All right, so again, this looks like exponential form, but not there yet. So again, there's two steps, and they're actually very similar steps to the last problem. Add 4 both sides, 2 parentheses, 3 to the 2t minus 5 is equal to 15. Got to get rid of this 2. Got to get rid of the 2. Cross out. 3 to the 2t minus 5 equals, I'm going to call that 7.5 for ease of use. And now let's put it into log form. Well, that's going to be log. This time the base of my exponent is 3, so the base of my log is 3. It's whatever's on the other side of the equal sign equals 2t minus 5. So we can put this log base 3 of 7.5 into a calculator using change of base. The way I would do that, log 7.5, close the parentheses, divided by log 3, close the parentheses, enter. Now to solve for t, all I know I have to add 5 and divide by 2. Solving for t, add 5, enter, divide by 2, enter. So 3.41 would be my answer. I can do it mostly on a calculator. If you want the exact work, 1.83 equals 2t minus 5. Add 5. Add 5. Now I'm obviously rounding. 6.83 equals 2t. Divide by 2, divide by 2. And that's how you're getting that answer in the calculator. T equals 3.42 if you want to round correctly. Alright, so there are some tricky ones. I can't say that it's always great to just look for going into from exponential to log form or log form to exponential. But I have told you in this class, when you see a trinomial, what do you always try to do? I hope you're saying factor. So when you're looking here, this is factorable. What we could write here, this is factorable as e to the x times e to the x. E to the x times e to the x is e to the 2x. So I know I have my first two spaces for these two multiplied to e to the 2x. So now we'll figure out the rest to make the FOIL work. That's going to be minus 2 minus 1 set up equal to 0. Now we're factored, and I actually can set up two equations. E to the x minus 2 equals 0. E to the x minus 1 equals 0. What you're going to do, add 2. E to the x equals 2. Add 1. E to the x equals 1. And here it's very similar work for both of these. They're both in exponential form. We're going to put them both in log form. And when I say that, it's log base e, so I'll be writing ln of what's on the other side of the equal sign. So that's 2. And here it's the ln of 1 equals x. So you have two separate answers to a problem like that. And that would make sense because x is being squared. You usually see two answers when x is raised to the second power. Alright, so most of the problems I've given you so far have been exponential form, and you've changed them to log. Well, here I have a log form, and we're going to change it to exponential. So that is log base e, e to the second equals x. Type it into a calculator, and you get your answer. If you want to leave it as e to the second, that's perfectly fine. You got to be careful. While you could do this by putting this from log form to exponential, that's slightly longer. What I notice is I have log base 3 of something on the left, and I have log base 3 of something on the right. Well, that means those two somethings need to be equal. So I can just solve the equation 5x minus 1 is to equal x plus 7. minus x, cross out. 4x minus 1 equals 7, plus 1 both sides. 4x equals 8, so I can make the conclusion x equals 2. Final answer. Okay. Same idea here. We need to take this and go from log form to exponential form. But right now it's not in log form. So minus 5, cross out. You get 2 ln x equals negative 1. Divide by 2, cross out. Ln x equals negative 1/2. So I go from my log base e, because that's what ln means. I have e to the negative 1/2 equals x. I can type that into my calculator and actually get an answer. So if I go second e to the negative 0.5, close, hit enter. So it looks like 0.607 is approximately my answer. It is worthwhile. When you're working with logs, you do want to make sure that you all your answers work. So sometimes because when you take a log, you can only take the ln of positive numbers. You want to make sure that your answers check. So if I just go back to the original problem, I could actually take the ln of that number, ln of that answer, that's the 0.606 number, hit enter, times it by 2, enter, and plus 5, and I should get an answer very close to 4 million. And the calculator is exactly 4, so I know my answer has checked out. It's always worthwhile to check your answers with and the reason is because the domain of your ln's only accepts positive numbers. So if you ever had this part of an answer being 0 or anything less, it wouldn't be a solution. So you have to be careful with some of the math. Okay, so the question is, this is not quite log form yet. To put it in log form, you got to get rid of this too. So that would be log base 5 of 3x equals 2, and take the base of my log, make it 5 to whatever's on the other side of the equal sign, equals 3x. Well, here it's 25 equals 3x, and that should be a relatively easy equation for you to solve. It looks like x is equal to 8.3 repeating. I could check it, but I can actually tell you I know it's going to work because I know when I multiply 3 times 8.3 repeating, I'm going to get a positive, and I know I can take the log of positive numbers. All right, so we have a lot of ln's here. In fact, there's 3 of them, so I actually would like to get it down to be just 2 ln's, one on the left, one on the right. Because I have a plus sign right here, I could write this as the ln of x minus 2 times 2x minus 3. It's using our properties of logs from the last section. And in fact, I could use a property here. I don't need to write this 2 in front. I hope you're thinking of a second spot I could write it in, and you could write it as an exponent on the x squared. So great. So now I have the ln of all this stuff on the left, and I have the ln of this smaller stuff on the right. And what that means is I can actually just drop the ln's. They essentially can kind of cancel each other out. And now I've got a FOIL equals x squared. So what I'm actually going to do is I'm going to FOIL this out, and I'm going to get 2x squared. That's our FOIL. I'm going to get minus 3x minus 4x. So I'm just going to go ahead and write minus 7x plus 6 equals x squared. This is a problem you solved before. I hope your strategy is get 0 on one side, because once you get 0 on one side, you're going to see a trinomial. Especially when you see a trinomial set equal to 0, you know what I'm going to say. Factor x, we're going to say minus 6 minus 1. This factors, and you're going to do all this work, and you're going to say x equals 1 and x equals 6. Now, be careful what I've been telling you these last 2 slides. Always check your answers. 1 and 6 are our answers. Well, if I put a 1 into this set of parentheses, I get an outcome of negative 1. Is it possible